Guys, welcome back to my YouTube channel. So today's Leetcode question is number 74, search a 2D matrix. So in this question, we are given a 2D array and a target. So we need to return true if this target is found in this 2D matrix, else return false. All right. So if and along with this, we are given the two properties of this array that are each row is sorted in a non-decreasing order, and the first integer of each row is greater than the last integer of the previous row. Right. So if we look at this array 2D matrix carefully, then we might notice that if we are able to write this matrix in a one dimensional or a single dimensional array, then we can solve this. Then like this array becomes like a sorted ascending order array, right? So, and also if we look at this, if we think about a brute force solution, so it would be simply just to, just iterate through this whole matrix and using two for loops. And if we find this target element, then return true. And its time complexity will be n square, big O of n square. But if we think about the intuition here, we will notice this sorted word. So So as soon as we notice this sorted keyword, then the binary search must come into our mind, right? So because we can think of binary search, and we have always done binary search question in a 1D array, then we can think of converting this 2D matrix in a one dimensional array. Because if we are able to do that, then it will just simply become a binary search question. So let's see how we do that. So, what we have done is that we have stored the length of this array in the m variable, and sorry, the number of columns in the n variable. And very similar like to the binary search, we have stored the starting index in the start variable and the ending index of this array in the end variable. So what is this m cross n into minus 1? So if we convert this 2D array into a single dimensional array, then it will have 4 ones are 4, 4 twos are 8, 4 threes are 12. So it will have 12 elements in total, and the index of the last element will be 11, given that we are starting our count from zeroth index, right? So that's why we have written m cross n minus 1. So let's start the binary search. While start is less than or equals to n, we will first calculate the mid element. So because we need to check this mid element's existence in a 2D matrix, hence we will convert this mid into a 2D format. So then the row becomes the quotient when we divide this mid by n, and the remainder becomes the column when we divide this mid by n. So then now we will be checking our the matrix or the mid element with the target. So if the target is less than or smaller than the middle element, then just like the binary search, we will reduce the end and store in it mid minus 1. Similarly, if the target is greater than the middle element, then we will be storing uh, into the start mid plus 1, right? And if we are able to find the target element, then immediately we will be returning. And while this whole while loop is running, and after we come out of it, then we will return false, because it means that we have not found the element yet. So the time complexity in this case will be big of log of m into n. Right. And if let us say the interviewer asked a brute force solution, then we told a brute force solution, and it asked us to optimize it, then we don't have to come directly to the binary search. Right. We need to find a solution that is more just a little more optimal than the brute force solution. So if we discuss this solution, then if we just this solution can be just solved using a little bit observation. So if we look at this array carefully, then we if we take two pointers I and j, I will be the row and the j will be the column size, right? So then we again try the while loop. Ignore this condition for a little while and just check your matrix ij with target. Target element, so if the target element is less than the current element, right, matrix at the location I, j, then then what we can do is, look, this matrix at the location ij is 7 in this case, right? And let us say the target element is 3. So what we will do, we will simply decrease the column size. Right, we will simply decrease the column size at 5, and now 3 is again lesser than 5, then we will again decrease this j, and then we will find our solution. Else, if the target is greater than this matrix ij, then what we're gonna do? Look, initially our j was at this position. So if the target is greater than this position, then it means that the target is not present in whole of this row. Right. So as we know that each row element, that the first element of each row is greater than the last element of the previous row. So we will do simply I plus plus. So let us say our target element was 11. So if we check first, so the target is greater than this ij, then we will do I plus plus. So it then the I will come on to this 1th position and the j will be in this column only. And now when we are at 20, we will check again. So now we will find out that our element is target is less than the target is less than this 20. So we will do j plus plus, then again j plus plus, till we finally find our element. And else, in this else, if let us say the target gets equal to this matrix ij position, then we will return true. Else, if we come out of this loop without any answer, then we will be returning false. So the time complexity in this case, in the worst case, is big O of m plus n. M plus n basically means a single traversal of all the row and all the columns, right? All the row and all the columns. So, for example, let us say our target element was 23. So initially we are at 7. So we will do I plus plus, then we will do again I plus plus, right? And now this 23 is less than 60. So we will do J plus plus, and again J plus plus. So in this worst case, we have traversed all the rows, which is m, plus all the columns, which is n. So that was our time complexity, and the space complexity was simply constant, right? So that was all from my side. Thank you.